Okay, so we're going to be doing the last primary lesson for trapezoids and kites in our quadrilaterals chapter right now. Um, Trapezoids and kites, it gets a little confusing in the sense that some of the rules are similar and some are even the same as some of our parallelogram rules. That's why when I showed you the tree diagrams, that's why there's some disparity, some differences between opinions on how those tree diagrams should be written. And it's because of all these overlaps that we're going to be dealing with. So I'm going to go through trapezoids, isosceles trapezoids today, as well as kites. So let's talk about trapezoids first. A trapezoid has one pair of parallel sides. That's the definition. Okay. And then something you may not have thought about is because of those parallel sides, it's got some consecutive angles that are 180. So what I mean by that is, let's say this is 70 degrees. This would have to be 110. Those add up to 180. Those are supplementary angles because these are the parallel sides. They're same side interior. And then the other ones are also supplementary. So let's say this is 95 degrees. This would have to be 85 degrees. So I'm just giving those numbers as an example of what I'm talking about. So that's about it. There's really not much going on with trapezoids. It's a pretty basic, very primitive kind of a shape. So if we make it pretty, and we make it isosceles, meaning we make the legs equal to each other, you increase the amount of facts we can talk about. So instead of just talking about these two repeat rules right here, there's three new ones we can talk about. The first one is basically the definition, the fact that these legs are equal to each other in addition to those parallel sides. That's what makes it isosceles. So think about isosceles triangles. You've got two sides that are equal. Well, this isosceles trapezoid also has two sides equal. Now, because you make this situation the way it is, I'm going to talk about something that is sort of pops up in this because I think it helps understand what's going on. A line of symmetry gets created. It's a very symmetric shape. And as a result of that, we got a couple things that happen. The first thing is we have base angles, because that's a base, those angles are equal to each other. And the same thing up here, those are equal to each other. And that sort of follows our rule about the line of symmetry. If this is a reflective line right there, those angles should be equal to each other. Additionally, those diagonal lengths, like a rectangle, are the same exact length. So this diagonal here and this diagonal here are exactly the same length. Unlike the rectangle, they do not get bisected. So although they're the same length, they would not be bisected. So what's interesting about this, there's some really high-end bookshelves. If you were to make a bookshelf that is more of an isosceles trapezoid bookshelf, it actually costs more money because people have to figure out more facts, more measurements. The angles have to be done just so. All these angles right here should be equal to each other. You got some supplementary angles going on. It's a harder piece to create and make, so it typically tends to cost more money if you actually were to purchase one of those. So that's it for isosceles trapezoid. So let's try some problems. For this problem, it doesn't tell you more than just that it's an isosceles trapezoid. And we know it's isosceles because of this. So if this angle equals this angle, then we can say 2x squared plus 19 equals 4x squared minus 13. This is one of the facts of isosceles trapezoid. Remember, there's that line of symmetry down the middle. If I solve this, don't get too panicky about the x squared quite yet. I'm going to subtract 2x squared from both sides. I get 2x squared minus 13 equals 19. I'm going to add 13. I get 32 equals 2x squared. Divide by 2, I get 16 equals x squared. If I square root, you get plus or minus 4 equals x. If I square root both sides. Now, can it be a negative 4? If I look back at the original problem, it can. So technically, it is positive or negative 4 is possibly the x for this problem. Looking at number 2, wow, there's a lot going on here. Another isosceles trapezoid. Let me color coordinate this a little bit. Let's talk about, let's talk about these angles right here. Well, 75 is not that whole angle. 75 is just this part right here. It'd be nice to know how big that is. Is there some other number in this picture that will help us figure out that number? It's hard to see. Let me give you a hint. If you look at the parallel lines and the transversal, you should be able to see that this has to be 22 degrees. So this entire angle has to be 97 degrees, and that is the same as 2. So angle 2 equals 97 degrees. So let me erase all my chicken scratch here, and let's get some stuff going on. All right. Oh, I'm supposed to erase all. I did nothing erased. This is 22 degrees down here. This is 97. This is 97. There's that line of symmetry going down the middle, so I'm going to tell you right now, this is also 22. This is also 75. There's a lot happening right there. So because of that, we can use the similarity in this picture to figure out solutions. And we're also going to use triangle sum theorem, in the sense that all three of those angles should add up to 180. So this angle here, let me write that in green, is 180 equals, let's call it x, plus 22 plus 22, or 180 equals x plus 44. 136 is x. So this is x right here, which means angle 3 is a vertical angle. That's also 136. That's interesting. And then the last one is more difficult to see. How we're going to figure out 1, look at this triangle here. If that's hard to see, I'm going to actually redraw this triangle. And I'm going to draw it with the things I know. They told us, well, you figured out, that this is 97 degrees. We know that this is 22 degrees. They want you to figure out that number right there. So that x is angle 3. That's one of our answers. Angle 2 was 97. This one, 180 equals 97 plus 22 plus that other angle. So let's start subtracting here. So 180 equals 97, 107, 117, 119 plus y. Subtract, I get 61 is y, which is our angle 1. There we go. That's a pretty tricky problem. Scrolling down here, let's talk about mid-segments. This is something new. So mid-segments, this line right here is the mid-segment of a trapezoid. It's actually the average of these two. What's sort of fun about it is if this is 8 and this is 12, this has to be 10 inches long. Let's do another one. If this is 6 and this is 8, this has got to be 7 inches long. If this is 20 and this is 40, this has got to be 30 inches long. The idea is if I've got two of the numbers, 20 and let's say 26, this is going to be 20 plus 26 divided by 2, or the average, or the middle number, like the midpoint of those two numbers if you put it on a number line. So 23 would be the answer. So this fact alone is going to allow us to do this. So in this first problem, let me write the numbers up on this picture. 8 is ED, LN is 15. They want you to figure out this number, SG. Well, we don't know what that is. All we know is that 8 plus x divided by 2 equals 15. That's the situation we're dealing with here. You can solve that like an algebra problem. 8 plus x equals 30. X has to be 22. So you could guess and check your way. The only problem with guessing and checking is if it's a decimal or a non-repeating number. You're going to be there for a long time. Let's try another one. Let's say ED is 3x, SG is x plus 4, and LN is 10. Well, again, 3x plus x plus 4. The two bases should add and divide by 2 to equal 10. So we can solve this algebra problem. I'm going to multiply by 2 and get 20. I'm going to combine like terms. Then subtract 4 and divide by 4. X equals 4 in this problem. Okay, that makes sense? Fantastic. Oh, I just stole the L. I'll write that L back in the the next section here. So that's it for trapezoids. So trapezoids, there's not a lot going on. There's a lot more excitement with isosceles trapezoids. We can do a lot more math with them. A lot of equalities going on in isosceles trapezoids. Kites are a weird animal. I don't know how to describe it other than the fact that it's just this weird standalone shape. It's got some similar kind of facts, but it doesn't really work perfectly. So I'm going to run through the rules for kites. Then I'm going to try and give you a single fact that will help you do most of the problems. So here's the definition. The definition of a kite is that you got two pair of consecutive sides equal. That means that these two sides are equal, if I color them in purple, and then these two legs are also equal. So we got equal sides, equal sides. You got two pair of equal sides. The rest of this is just like weird things with diagonals and angles. So for example, a weird fact is that these angles right here, like the wings of the kite, those are equal angles. They're the same size. The other two angles are not the same size. The diagonal, if you look at the diagonals, one of the diagonals gets cut in half. One diagonal gets cut in half. The other diagonal does not. The diagonals are perpendicular to each other. So these are perpendicular. It's not a coincidence. And a diagonal, one of those actually cuts the angles in half, but not all the angles get cut in half, just one. So it's actually the ones on the top and the bottom get cut in half. Now, there's a lot going on there. There's a lot of weird facts. You might feel a little overwhelmed. So let me boil all of this down for you. You have to know what a kite is, okay? You cannot get past that part. So you do need to know what a kite is. The other 4 facts about kites can be explained by a line of symmetry down the middle. It will tell you which two angles are equal. It'll tell you which diagonal got cut in half. It'll tell you which angles got cut in half on the top and the bottom. That line of symmetry right up and down the center of this is going to help explain the other 4 facts. So that line of symmetry is key. It even explains the perpendicular line, honestly. So if these are both equal to each other, that's only possible if they're both 90 degrees. All right, so line of symmetry down the middle for a kite is going to help you. Line of symmetry down the middle for an isosceles trapezoid is going to help you minimize the amount of facts you're going to need to memorize. So let's do a couple calculator problems. A couple kite problems, I should say. So here's this picture. They tell you QPO is 42 degrees. 42 degrees is right there. OSR is 68 degrees. That's right there. QS, I'm looking for it. Oh, this diagonal is 16. I'm going to write that because that's the one that gets cut in half. I'm going to write that as 8 and 8. And then PQ, this side is 17. There's a lot going on here. So let's first add some facts. So fact number 1 I want you to realize is there's a 90-degree angle right there. Those are perpendicular diagonals. The other thing is we can say this is 17 because the other side was 17. That's helpful as well. We can say this is 42 because the other side was 42 as far as the angles are concerned. This is 68, this is 68 because there's symmetry going on there as well. So you actually have quite a bit of information given to you. So let's see if any of this is helpful. First thing I want you to do is find angle 1. So looking at this triangle, you actually know 2 of the 3 angles. So you can subtract from 180. So to figure out angle 1, let me just do a little bit of scratch work here. 180 equals 68 plus 90 plus angle 1. So that's 90 equals 68 plus angle 1. So 68, 78, 88, that's 22 equals angle 1. So 22, that's that answer. Let me just move this work off to the side here. All right, there's that. Angle 2, let's see what we can do for that one. Oh, again, let's highlight a triangle here. We know 2 of the 3 angles in this picture. See how we got the 42 and the 90 degrees? So it's the same situation. If you'd like to do, instead of supplementary, you could say 42 and angle 2 add up to 90. So that would be angle 2 is 48 degrees. Angle PSR, oh, we figured out this was, I should probably write these numbers in here. This is 48 degrees, 48 degrees, 68, 68, you got that. Angle 1, 22 and 22. Just writing in things we've learned. So PSR is if I add 48 and 68. So 40 plus 60 is 116 degrees. PQR is the same, 116 degrees. That was easy. QRS, 22 plus 22, that's 44 degrees. QO has to be 8. We figured that out early on. PS is 17. We're going pretty quick now. QOP, oh, that's the 90 degrees. That's easy. And then challenge, OP. Well, let's look at that brown triangle. Let's look at only the sides. It's a right triangle. It's 17 and 8. They want you to figure out this side. How could we do that? That's right. You can do Pythagorean theorem. So 17 is the hypotenuse. That equals 8 squared plus x squared. Let me get my calculator on my phone to calculate 84. Let me find that. 1 second. There it is. So 17 squared is 289. 8 squared we know is 64. Subtract 64. And I get 225. Ooh, this is a perfect square. And if I square root both sides, I get 15. And that is OP. There we go. That is it for the lesson. So there's the idea. So you've seen it all now. You've seen isosceles, trapezoids, and kites today, and we saw all the parallelogram stuff in the past. The rest of this chapter is just to memorize these, use these in different kinds of problems, and hopefully walk away smarter than when we started.